our discussion regarding the universal shift register. In this universal shift register, as its name suggests, we need it, like we have talked about universal gates. Okay, if you remember. So what was the feature of universal gate? With the help of universal gate, we can design any of the basic gates. Similarly, in the case of universal shift register, we can design or we can have any of the basic shift registers. Okay, and apart from regular inputs, what we have discussed, like parallel in, parallel out, serial in, serial out, we have this preset control, shift pulse, and clear control. So these things we have already discussed in the previous lecture. So let's move to the designing and working of universal shift register. So have a look in this diagram. This this shows the universal shift register. Okay, these all are your D flip-flops. These all are your multiplexers, and I hope that you must be remembering the operation of multiplexer. Like we have 4 input and 1 output. Although the multiplexer we have placed here is not as we have did in the previous discussions, uh, because in this case the inputs are placed downwards, no? And in our discussion we have placed input toward the left, so that is just we have changed the orientation of multiplexer, nothing else. Okay, these two are representing the selection line. These are the 4 possible inputs, and this is the output y. Okay, now let's say if you have given 0 0 for this. See, if you have given 0 0, okay, wait a minute. So now this, if you are giving 0 0 at the input of this, these inputs will change to 0 0. In that case, all these multiplexers, okay, which of the input of this multiplexer will be selected to the output? This 0th. And if this is selected, this input is selected to the output of multiplexer, then the content of register won't change. So that is why it is represented as no change. Okay, so if I have selected 0 0 from a select input, in that case there won't be any change in the content of registers. Okay, now let's say I have changed my input to 0 1. So the expected operation from this is shift right. Okay, now let's see what will happen with the help of animations. I have selected shift right operation, or I have given 0 1 at my multiplexer. So if I have given 0 1 at my multiplexer, which of the input will be selected to the output? Obviously the first one. Okay, that's what I have did here. Now this will be connected to the output, and output of this multiplexer is connected with the input of flip-flop, this D flip-flop. Okay, so now this output is connected with the input of flip-flop. Now these things will prevail further, and you will see how the information or content, now this D or the output of this flip-flop is connected to the input of first input of the multiplexer, and we have already selected this first input of the multiplexer. So this thing will continue, and this is how you will get or you will achieve the shift right operations in the multiplexer or in this universal shift register. Now let's say if you want to perform shift left operation. Okay, so for that, for shift left operation, you have to simply give inputs as 1 0. Okay, so here we goes. I have given my input as 1 0. Okay, if I have given 1 0, then what will happen? Then obviously second input of multiplexer will be connected to the output. Okay, here we goes. See, and in this case we are intended to perform shift left operation, no? So whatever information or data we want to store in this will place on the left side. Okay, here we goes. Now this output will be connected to the input of so this input will be connected to the output of multiplexer. Okay, so this, and further it is the input of D flip-flop, so this data will be available here. Okay, and we'll proceed further, and by if you have understood the previous one, then by following the same way you can understood this also. The output now is shifted toward left. Okay, and see the output of the D flip-flop, or the information what we have stored in the multiplexer, that is connected to the input of D flip-flop, and the output of D flip-flop is connected to the the output of D flip-flop, this output of D flip-flop here. So see here the second input is connected to the output of multiplexer, and the output of multiplexer is connected with the input of D flip-flop, and the output of D flip-flop is connected to the next multiplexer. Okay, So from here the data will travel through this path and it will reach to the output. Okay, so this is how you can perform shift left operation. Okay, now let's talk about the next possible operation, that is parallel load. In this case, as you can see, we have to give 1 1. If I am giving 1 1 as my input, then third input will be connected to the output, see, and that will be directly connected to the output. Simple. Okay, so that is how you will achieve all the basic main operations, register operation in one circuit. That is why it is known as universal shift register. Okay.